So in talking with a friend last week, I realized that I need to make clear a little bit more really what the basic functions of a computer are. Some people think that the growth in compute capacity means that now computers, we don't have to think about physics anymore with computers, that they can just do anything. The way a computer works is still the same that it's always worked, to be honest with you. It hasn't really changed in the last 100 years in very dramatic ways. There's improvements that have been made, but the basic premise of it, in at least the last 50 years, is very consistent. To understand how a computer works, instead of going through the typical discussion of an engineer, I thought it might be easiest to use the analogy of a meeting. A meeting would be a single computer, single node of a computer. Computers today can sometimes be like buildings that have multiple meeting rooms in it, and inside of each one of those meetings is a CPU. But each CPU core is a single meeting with people, with a whiteboard, and with notes being taken and a telephone. So the pieces of the computer then are the people in the room are the CPUs. They're the only things that think. They are the ones that do the actual work involved. They're really the brains, like the CPU is of a computer. The whiteboard of a computer is like memory. The memory is very fast. It's very easy to look at, very easy to access, but it's also limited in that there's not a lot of whiteboard space when compared to like a notebook. The whiteboard is a limited thing, and it's also fragile. You don't know between meetings, overnight, even within a meeting, if the data that's recorded on the whiteboard is going to stay there or it's going to get erased. So the whiteboard is fragile and limited, just like memory is. Then you have things that are permanent and voluminous. Those would be notebooks. For taking minutes, for writing things down, loose leaf binders, all of those kinds of things are disk. They're very permanent. And you can put a lot of things in disk. It's very inexpensive to add disk, much more expensive to add whiteboard to a meeting room. But the problem with disk is that it's slow. So it takes a long time to get out of binders data onto the whiteboard so that people can see it. Because people can only interact with the whiteboard. They can't really pass around a binder in a meeting and have a very effective meeting. You have to have the data on the whiteboard. So the process of getting the data from the disk, from the binder onto the whiteboard, the memory, is a slow process, but it goes on, and we have to do it because we have to keep permanent copies of things. We can't just rely upon the data written on the whiteboard. The CPUs then interact with the whiteboard. That's where all the work goes on. They change things. Everything that they do interacts with the whiteboard. Then you want to make a permanent copy of what's been done. That gets written back into a binder. Again, that's a slow process. In fact, writing has historically been about 3 times slower than reading. So getting data onto the whiteboard goes faster than getting data off of the whiteboard. When you think about what goes on the whiteboard, there's a couple of different parts to memory. One part of memory is the data, things like that would be in your Excel spreadsheet or in your word processing document. Those would be the data part, but also Excel and Word and the other programs, those also exist in memory. Those are the agendas. The agenda is written on the whiteboard, and the CPUs use the agenda to tell them what to do with the other parts of the data on the whiteboard. There is a telephone in the room, and we can actually include other people that might be in other conference rooms or other locations. That's a network connection. We don't know really what's on the other end of that network connection, although it has to have a person of some kind, but maybe the data is coming from a whiteboard, maybe the data is coming from a disk. We're not quite sure about that. But the process of going through the telephone line is the slowest data transfer process of all of our mechanisms. The whiteboard is the fastest, the disks are faster, the telephone line is the slowest. So those are the pieces of a computer come together. We'll use these again as we talk in our next episode about how this applies to big data and why you should care about the meeting analogy for how a computer works.